Okay, so today we're going to go over algebraic proofs. But before we do that, we need to kind of familiarize ourselves with some properties. These are all properties that you've used before, but we kind of just need to address them again. So these first four are addition, subtraction, multiplication, and division properties of equality. So these are just your basic symbols. You're adding, you're subtracting, you're multiplying, and you're dividing. And they're basically just saying, hey, if you do one of these things to one side, so if you add c to one side, you got to add c to the other side. Or if you subtract, you got to subtract from the other side. Or if you multiply, you got to multiply to the other side. Or if you divide, you got to divide on the other side. So those are something that we're pretty familiar with. We do pretty frequently. The next property is called the distributive property, and I like to draw a little like rainbow because that's what I do with it. I multiply a to the b and a to the c and kind of draw a little rainbow for everything that I'm going to distribute. Over here we have the reflexive property. And reflexive is pretty straightforward. It's just basically, if something, a is going to equal a, or x equals x, something equals itself. And we generally will see this in reflexive property of congruence when we see something like this. We'll say, hey, we have segment AB. Well, that equals segment AB. And so that's a reflexive property. And symmetric property is pretty similar. If A equals B, then B equals A. But in geometry, we'll kind of see it like this. If A equals B, then, or I'm sorry, if you have AB here, well, you could say, well, that's the same thing as segment BA, right? You just flip the order, but it's still the same thing. And the transitive property, I kind of like to think of a train. So like here, I'm going to take the A train to B, take the B train to C, but I could have just taken the A train straight to C, right? So you kind of skip the middleman there. That's a transitive property. And then substitution property just says, hey, if you have A equals B, then you can plug in B for anywhere that you have A and vice versa. So if I had some expression, like 3x equals 12, and I knew that like x equaled 5, I could plug that in and I could say, well, actually that wouldn't work. Let's say x equals 4, right? I could plug in a 4 and I would say, hey, 3 times 4 equals 12, right? Because I know that x equals 4, so it lets me substitute it in. That's what that means there, substitution property. All right, well, all that is so that we can use these in algebraic proofs. And this is what a proof looks like. Okay, we have 2 columns, statements, reasons, and they're usually going to give us something called a given. This is just kind of like our freebie of information, and that's where our proof usually starts. And there's usually also a drawing too, not always, but usually some type of drawing that we can gain information off of. And so this one says LM bisects KLM. That is my first statement. And usually in my proof, that's the first thing I'm going to write down. Not always, but usually. And then over here in the reason category, I'm going to write, well, how do I know that? It's given. Every time for what I'm writing in the reason category, the question is, how do I know that this statement over here is true? And then I write the reason that I know that over here. All right, so they're telling me that LM bisects angle KLN. Here's KLN, and here's LM. Well, if this angle is being bisected, that means that it's being cut into 2 congruent angles. So those 2 angles are congruent. And so I can say that. I can say, hey, angle MLN is congruent to angle KLM. And notice I'm using the congruent symbol there, but here we go down to equal sign. And that's because I can transfer from congruence to equality when it comes to angles because that's just the definition of congruent. If these 2 things are congruent, then their measurements are equal by definition. Oh yes, and the reason I'm able to say these 2 angles are congruent is because that's just what an angle bisector does, is that it cuts it into 2 congruent angles. So by definition of an angle bisector, these 2 things must be congruent. And then by definition of what congruent actually means, these 2 things must be equal. And now look, I'm substituting in 4x and 2x plus 40 because 2x plus 40 is what KLM equals and 4x is what MLN equals. So I'm just substituting those in, so I'm going to write that as the substitution property of equality. And now I did use a little shorthand there to just write sub. I do that in my class and my students. I let them do that. And the way I tell the difference between this shorthand and subtraction is that I will write the subtraction property like this. Subtraction property of equality. And we're in math. I don't mind us using little shorthands to get through things a little bit quicker. Okay, so subtraction property of equality. And so they're telling me in this proof that that's actually what I'm going to do next. I'm going to, over here, I'm going to subtract something from both sides to get this, to eventually solve for x. Well, what I would subtract from both sides is 2x, so that I get all the x's on one side. If I subtract 2x from 4x, I get 2x. And if I subtract 2x from 2x plus 40, I just get 40. Alright, so I'm a little bit closer to solving for this. My next step, though, is I'm going to divide both sides by 2 to get the x all by itself, and that's actually how I get x equals 20. But what's the property that I'm using? Well, if I'm dividing both sides to get x equals 20, then that means that I'm using the division property of equality. And there we go. I have my proof. I have all my statements down to the very last thing that I was trying to solve or trying to prove. And in this case, I was trying to prove that x equals 20, and I did it. And I have all my reasons to justify each of my steps. So I didn't do a single step that didn't have a justification with it. Everything was justified. Everything had a reason for it. Okay, let's go on to the next video. Okay, so here's another proof. This one, not using angles, instead we're using segments. So we have this distance AB, which they say is 4y minus 3, and this distance BC, which they say is 2y plus 1. And over here in the given, they tell us that AC equals 46, so this whole distance is 46. So this is going to be a segment addition postulate problem, and sure enough, they even put that as our reason in step 2. We're just going to add this segment and this segment, set it equal to this whole segment, and solve. Well, let's start off. AC equals 46, that's my first step. How do I know that? Well, it's given. It's just given information. Next up, they fill in 4s, and this is just what the segment addition postulate says, that if you have some segment AB and some other segment BC, that if you add those two segments together, it should equal the whole segment, or it will equal the whole segment. And that's the segment addition postulate. So we start there because now we can actually plug in our values, right? I know that 4y minus 3 is AB, so let's plug that in, 4y minus 3. And I know that 2y plus 1 is BC, so let's plug that in. And I know that AC, the whole distance, is 46. Well, how did I know that? How was I able to plug in those numbers? Well, that's just the substitution property. All I did is substitute in all the values that I already had written down here. So I substituted them in. So we're just going to call that the substitution property of equality. Alright, the next step is I got to simplify this thing a little bit, or I got to combine like terms. So I got a 4y and a 2y, so I'm going to call that 6y. And I got a negative 3 and a positive 1, so I'm going to call that negative 2. And the 46 stays the same. And so what was my justification or my reason for doing that? Well, in geometry and algebra, we just call that simplify. Because that's all we did. We just simplified the expression. We didn't really change anything. We just simplified it. All right, well, my next step is I got to get rid of this negative 2. So I'm actually going to add 2 to both sides here, leaving me with a 6y here and a 48 here. And so what did I do to get there? Well, I added 2 to both sides. So the property that I'm using is the addition property of equality. And I'm not really done yet, so there's actually one more step on here than I put on here. And that's okay. My last step to get y all by itself is divide both sides by 6. So let's do that. If I was to divide 6y by 6, I would just get y. And if I was to divide 48 by 6, I would get 8. Let's change back to red. And so over here, my reason for being able to do that is that's just what the division property says, is that if I divide one side, I got to divide the other. And so I do, and I get y equals 8. Okay. The next one here, I think that you guys could do. It follows relatively the same pattern. It's really similar to the one above, but I just want you guys to kind of be able to think about it. Try it, fill it in on your own. So go ahead and pause the video now. And I actually forgot to tell you just a couple of little things. One, there's a little bit of a typo. The A should be here, the B should be here, and the C should be there, not there. Sorry about that. There's a little typo there. And here, this statement down here, this is actually a typo as well. This actually should be 7x equals 60. It was a little typo when I made this. Sorry about that. Should have fixed it before I uploaded it, but I forgot to do that. So, okay, now try it on your own. Okay, here's what your answer should look like. If you need to check your work, you could pause the video and just check it, but yeah, that's what it should look like. So I'm going to move on. Lastly, all those properties that we just learned, some of them actually have relevance in the area of congruence as well. So these are properties of congruence. So reflexive property, symmetric property, and transitive property, they all have to do with congruence as well. And the basic difference is just, hey, if we're using a congruent symbol like you see here and here, then this is a a congruent problem, not an equality problem. So you just need to know that's the main difference that you'll see. Usually we're talking about congruence, we're actually talking about an item, and when we're talking about measurement, or we're talking about equality, we're talking about a measurement. So that's kind of the general difference of those two. But the rules involving the properties are pretty much the same. So reflexive property, you could see it looks really similar. Transitive property is the same idea. And symmetric property, right, just flips it. So yeah, nothing too crazy about that. So let's identify the property of equality or congruence. Well, this first one, xy is congruent to xy. That should be pretty simple. That is just the reflexive property of congruence. Take a look at this next one, see if you can figure out what it is. If you want to pause the video for a second, try it on your own, you can do that. Go ahead and pause it now. Okay, well, you may have noticed, but you got A equals 45 and 45 equals measuring angle B. So we could have just skipped the middleman there, the 45, and we could have just gone straight to measuring A equals measuring angle B. So that is the transitive property. But look, is it of congruence or is it of equality? Well, we're using equal signs here. So it's a transitive property of equality. That's it. All right, thank you very much. See you next time.